Today we're going to continue graphing with linear and exponential functions with Unit 2. So far we have been doing graphing linear exponentials. That's when we just have a regular line. So now we're going to move on to exponential functions. And let's write down our learning target for today, which is, let's write it all together. I can graph an exponential function and show the y-intercept. So again, I can graph an exponential function and show the y-intercept. Let's make it a little better here. There we go. So the first thing we're going to try to graph is, well, before graphing the exponential function, we need to know what is an exponential function. And over there in your notes, you have to fill out the blanks. And it's an exponential function. It's when the what is in the what. So basically, an exponential function is when the x, let me choose a pen, when the x is the exponent. So how does it look a function when the x is the exponent? Easy example, very simple. It's f of x. So remember, f of x is also y. So f of x equals 2 to the power of x. Remember, f of x is y, so you can rewrite it as y equals 2 to the power of x. Exactly the same thing. And one way to graph it, it's starting with a simple table, with the x and y table. So basically what we're going to be doing, we're going to be choosing numbers for x, and we're going to be plugging an in over here. So for example, we can choose very simple like -3, and then -2, -1, 0, 1, 2, and 3. And let's see what happens when we plug in these numbers. So over here, and y equals 2 to the x, or f of x equals 2 to the x. Let's see, y equals 2 to the, instead of the x, we're going to replace this -3 into this x right here. So it's going to be 2 to the -3. And just a reminder that going back to the beginning of last year, negative exponents, it means that we're going to be doing the reciprocal, or that we're going to be changing this number into a fraction. We're going to move it down. So it's actually 1 over 2 to the third power. So again, we change this number into a reciprocal or switch it into a fraction. And once we do that, the exponent is not going to be negative anymore. It's going to become positive. So now let's just finish the work. What is 2 to the third power? Remember, that is 2 times 2 times 2. So if we want to write it down, it's like this. And that is actually 1, y equals 1 over 8. And to graph it, it becomes a little bit harder. So we're going to be using just the calculator in the computer to figure it out how is exactly 1 over 8. So let's check over here. I think I closed the calculator. But 1 over 8 is exactly 0.125. So if you notice, that is like 0.125. It's not even 1. So let's put it over here, 0.125. Again, not even 1. So we're going to go to -3 and then a little bit up. Just barely on top of the 0. Barely. And we need to do that with all the numbers. So let's now plug in the -2. Let's see what does it give us. And we're going to try to move a little bit faster. So y equals 2 to the -2. Remember, reciprocal, so we switch it into a fraction. And now the exponent is positive, so y equals 2 to the second power is 1 over 4. And 1 over 4 is just 1.25, or 0.25, if you want to have the 0 before. And then again, it's like a little bit, you go to -2 on the x, and a little bit up. Now, let's try to the -1. So y equals 2 to the -1. Again, negative reciprocal, switch it in, or flip it into a fraction to the positive one, and that is just 1/2. which is 0.5. So 0.5, like in the middle, right here. And the next numbers are going to be a little bit easier because now the numbers are positive, so your exponents are going to be positive. So y equals 2 to the, which is the next number, 0. I don't know if you remember, but any number to the 0 power is a number that is always 1. Doesn't matter what number is the base, it is always going to be 1 if your exponent is 0. So let's put the 1 here. So 0x, so we stay here, and then we move 1 up, right here. And let's finish our table. So that will be y equals 2 to the 1 power. Well, 2 to the 1 power is just 2. So the 2 belongs here, and we're going to go in the x's to the 1, and then move 1, 2 up. And let's do the next 2. So it's going to be 2 to the second power. And remember that is 2 times 2, which is just 4. So we're going to go 2, 4, so 2 to the right, and then 4 up. Right there. And the last one, I know it seemed kind of long, but you should be doing it faster than me. It will be y equals 2 to the third power, which is 2 times 2 times 2, and that will be 2 times 2 is 4 times 2, that's 8, so over here 8. Now 3, 8, so 3 to the right, and then 8 up. And I don't know if you remember, but when we were talking about exponential graphs last semester, we said it would look something like the Superman ride on Six Flags. So where you start going like all horizontal, and then suddenly you start going like up, and almost go vertically. So I'm gonna try to do my best over here for the graph. It is almost horizontal here, really next to the 0, so it goes up, and up. So I hope that I don't mess it up here. So it's not that bad. And that is just an approximation of how it looks. How it actually looks, there's a really cool graphing calculator online where you can just put the graph over here. So it was 2 to the x, right? So 2 to the with the exponent x. And there you go. It gives us right away. So if you notice, this point is 0, 1. Let's just double check what we graph. 0, 1. Exactly the same point. And my graph might not be as good as this one, but it's exactly the same point. So our graph is an approximation of this. So now let's go back to the presentation. So this is just graphing, but we need important information about this graphing. These are the important points. So the origin, remember the origin is kind of the center of your coordinate plane. And the center, it's right here. Let's change color so we don't get confused. The center is right here on the 0, 0. So your origin, it's 0, 0. Now, the next word, asymptote, is kind of a new word we haven't used so far. So an asymptote is gonna be a line that your graph is never gonna touch or pass through. So again, an asymptote is where your graph is never gonna pass. So for example, if you notice, let's go back to the graph in the internet. If you notice your graph, it looks like it's on top of this line, right? But it's actually not on top. Well, you can say it's almost on top of it. So over here, it goes like up, up. And if we move the graph over here to the right, you'll notice the blue line, which is your graph, it will never cross through here. It will stay right there. So that's what we call an asymptote, exactly where the line will never cross. And there's a way just to say, oh, here's the asymptote. We use a dash line. So we know that the asymptote is going to be right here because our graph is never going to cross this line. That's basically your asymptote. And we need to make we need to label it or name it. So the name for this line, it's a horizontal line. And usually when we have horizontal lines is when we call y equals and the number. And it's on top of 0. So it'll be y equals 0. That's the asymptote. Y equals 0. Now the next one, it says points from origin. So we're asking for the next 2 points like in the origin, here's the origin, which are the next 2 points? Well, here's the first point and the second point. So we're going to be labeling these points. If we go back to our graph, it's going to be the one on starting on 0 and the 1. So when you plug in 0 and when you plug in 1, you're doing this too. So points of origin, first 2. That will be 0, 1. And the second one is 1, 2. So again, when it's asking you for the points of origin, it's going to be the first 2 that you plot starting from the 0, which are these 2. The one when you put in 0 and when you put in a 1. And the last one, the y-intercept. So the y-intercept is kind of the same one. The y-intercept is where your graph crosses the y-axis, which is also right here. So it's also going to be that point. So it's 0, 1. So that is all the information they're asking us for about this graph. And it's kind of basic. Origin is the center, the middle of your coordinate plane. The asymptote, where the graph will never pass. The points from origin, which are the first and the second point after the origin, after the origin. And the y-intercept, where exactly the graph crosses the y-axis. So now I'm going to let you practice the next one. So over here, I'm going to ask you to pause the video and try to follow the same steps. If you need to go back over here, move it a little bit, the bar from the video, so you can go back to review how we got the other points. So I'm going to ask you to try to do this one now. So go ahead and pause it, and you'll hear from me in a few more minutes. So welcome back. Here is this year we're working on y equals 3 to the power of x. And just to show you the results, just to double check that we are correct, our table should look something like this. So -3 was 1 over 27, which is 0.037. -2 is 1 over 9, which equals 0.111. And -1 is 1/3, which is 0.33. 0 is 1, 1 is 3, 2,9, and 3,27. Obviously, the 3,27, we cannot graph it because it goes like outside our coordinate plane. The origin, again, is the center, 0, 0. The asymptote, you cannot see it. The asymptote is, again, the same line, y equals 0, because our graph will never pass through here. It always stays there. And the 2 points after the origin are here and here, which are the ones where I put the little asterisk, and the y-intercept, it's 0, 1. So far it's good. Now, the next one that we're gonna do in your notes, it looks a little bit different. Well, you know what? Let me stop. Let me go back to the one online so you can see how it actually looks. So we're gonna change this 3 into a 2, so you can see how the one that you were doing looks like it. It's not so different. So now this is the one that you were doing so far. So I know it looks way better in here than in our drawing, but we're just trying to approximate, so it's okay. So the next one is going to be a little bit different. It's also going to have the 2x, like the first one that we did right here. But if you notice, this one, it has the 2x alone. This one is going to have the 2x plus 3. So that's the only difference, the plus 3. We're going to do almost the same thing. So over here, we're going to put the x and the y, and we can choose the same numbers. Actually, you know what? Let's choose from, no, it's fine. Let's choose from -2 to 3. So -2, -1, 0, 1, 2, and 3. Let's move this bar over there. So if we plug in the -2, we're going to have, remember, f of x also means y. So y equals 2 to the -2 plus 3. Remember, negative exponent, switch it into a fraction. So 1 over 2 to the second power plus 3. That is 1 over 4 plus 3, which is 3.125. So let's put it over here, 3.125. And so we're going to go -2 to the right and then 3.125. So 1, 2, 3 up. and a little bit more up than 3 because it's 0.125. There you go. Now let's try the next number, -1. So it is y equals 2 to the 1 power plus 3. Y equals, well, I'm sorry, I'm lying, -1. My bad. So that's switching to a fraction. That's 1 over 2 plus 3. And 1 over 2 is actually just 0.5 plus 3. So this is 3.5. So again, we go -1, so 1 to the left, and then 3 up and kind of in the middle, right here. Let's do 0, which is kind of one of the easiest ones, if not the easiest. So y equals 2 to the 0 power plus 3. Anything to the 0, it's 1. So it's going to be 1 plus 3, which is 4. So on 0, we go up 4. Then let's do 1. So that will be y equals 2 to the 1 power plus 3. Now our exponent is positive, so very good. 2 to the 1 is just 2, plus 3, that is 5. So 1 to the right and then 5 up. I'm just going to switch colors over here to do 2. So y equals 2 to the 2nd power plus 3. 2 to the 2nd power is 4, plus 3, that is 7. So 2 to the right and then 7 up. And the last one. The last one is y equals 2 to the 3rd power plus 3. And 2 to the 3rd power, remember, is 2 times 2 times 2, which is 8, plus 3, which is 11. And, well, we can try it over here and do it a little bit more up. So just an approximation, because we run out of coordinate plane, it must be right there. So now, if you notice, your graph is not right here. Remember, the asymptote usually was right here. Like, our graph will never pass through here. So from here, it's not gonna go down. So let's see how it might look. So when we do our graph, I'm gonna try to start from the top. Let's see how it goes. If not, we just erase it. So it goes like this. So remember how the asymptote, usually we had it right here? Well, our graph is not gonna do this here, because this kind of looks weird and it doesn't look like the ride in Six Flags, the Superman ride. So our graph is actually gonna keep going here. This is gonna do the same thing. It's gonna keep going, and now it's never gonna pass this line right here. So now this line is gonna move up, if you notice. So the previous graph, let's show them together on the other one. So let's erase this one, and over here was 2x. And the cool thing about this app is that you can put together both graphs. So over here, we're gonna put, this is the blue one over here, and no, I'm like, it's 2 to the x power plus 3. So if you notice, the blue one is the first one that we did, the 2 to the x power. And the second one is 2x plus 3. So basically what we did, we took this graph and we move it 3 places up. So let's see if I can zoom out. No, zoom in, I guess. So here it is, a graph. I really zoom in. And this one started on 0. And the y-intercept was right here. And this graph is exactly the same as this one. We just kind of move it up. So let's zoom out, so you can see it right there. So we move it up from here. So it's kind of the same graph, just like slide up. So if it's moved up, our origin is not going to be here anymore. It's not going to be on 0. So we're going to have a new origin over here. So it's not going to be this one. Well, the origin of the coordinate plane is this one, but if we're talking about this graph, we're going to kind of have a new origin. So we need to figure all that information. Um, let's see, our asymptote will not be here either. It will be 3 places up. So let's use another color just to do a dashed line through our asymptote. Right here. So let's go back a little bit because I want you to see some, well, this one will be fine. You notice how the origin was through 0 and the asymptote was also in 0? So the origin and the origin and the asymptote should be on the same place. So over here, the new origin will be right here on y equals 3. So the origin will be, well, I'm lying, the origin will be here. The point, sorry, this is the asymptote, y equals 3. The origin, the new one, will be right here on 0, 3. And let's make a connection. The origin and the asymptote are kind of together. And just look over here, plus 3. So whenever you have plus 3, your graph is going to move up 3. And well, if you actually had minus 3, your graph will look the same thing, but now will move down 3 places. Well, from here, from the origin, it will move down 3 places. So we need that important information. So let's continue. Points from the origin. So remember, those ones are just the next 2 points after we do the origin. So this one and this one. Or when you plug in the 0 and when you plug in the 1. So over here you should have 0, 4 and 1, 5. And the y-intercept is right here also because that's where your graph is passing through the y-axis. So let's put it 0, 4. And it might look a little bit confusing, but once you start practicing more and more, it's going to get less confusing. So let's talking about practice, let's practice the next one, which is f of x equals 3 to the x power minus 4. So I'm going to ask you to pause it and keep working on it. So welcome back. And here's the one that you were working on. And let's see the answers, or kind of the answer. So negative 4, you should have the same graph, but it should have moved 4 down. So remember, this is just an approximation. Your table should look something like this over here. And your origin, the new one, so let's put over here new, we forgot about the new part, is going to be on 0, 4. So right here, let's use another color. Right here, your asymptote was on y equals 4. So right here, your points from the origin, oh, oops, we forgot to put the other one. It's 0, 3, which is right there. We forgot the other one, the next one, which is right here. 1, 2, put the parentheses, and 1, 2. And the y-intercept is right, this one again, the 0, oh my goodness. I know what, made a mistake. Over here was 0, 3, negative 3. Because it's right, this one, the y-intercept. So let's check your answers and make corrections. And we might keep practicing right now. So you can pause the video and you can raise your hand just to let me know that you're done. And we'll see if we need to keep practicing or we're ready to move on.